Thank you for giving me this opportunity to present our recent work. I will talk about impact of short-term oral dose of cinnamotane A2 and epicatekin tetramer on spatial memory and adult hippocampal neurogenesis in mouse. In recent years, the target of functional research of B-type proteins has shifted from peripheral tissues to the central nervous system, and a number of intervention studies and meta-analysis of the results have suggested that some consumption of food rich in B-type proteins maintains and improves cognitive function. However, there is no evidence that polyphenol intake has any effect on cognitive function. However, the details of how polyphenol intake affects cognitive function remains unclear. In the present study, we examined whether short-term administration of cinnamotane A2 and epicatekin tetramer as a model chemical in mice would affect spontaneous behavior, spatial memory, and recognition memory. We also use immunohistochemistry to observe adult neurogenesis in the hippocampus by detecting the uptake of bromodeoxyuridine (BRDU). We used male black 6 mice as experimental animals and divided into two groups, vehicle or A2 100 microgram per kilogram treatment groups. After 2 weeks habituation, the animals were oral administered vehicle or A2 for 10 days. Then, mice were conducted behavior tests and sacrificed by decapitation. We made coronal frozen section of hippocampus and observed adult neurogenesis by detecting the uptake of BRDU using with immunohistochemistry. The results of open field tests are shown in Fig 2. There was no difference in the total travel distance between the experimental groups. In addition, the time spent in the center area trended to increase in the A2 treated mice. The results of the object location test are shown in Fig 3. In the vehicle group, the exploration time for objects in different locations was constant, but in the A2 group, the exploration time for the object in different locations was significantly longer. In addition, the total travel distance was significantly increased in the A2 treated group. Fluorescent immunostaining was used to detect BRDU labeled cells in the hippocampus, and the result was shown in Fig 4. In both experimental groups, a small number of labeled cells were found throughout the hippocampus. In particular, in the hippocampal dentate gyrus (DG), A2 treatment significantly increased the number of BRDU labeled cells compared to the vehicle treatment group. Our group found that A2 intake fires the noradrenaline network that controls the hippocampus, which performs memory and cognitive functions. The present study suggested that short-term repeated ingestion of A2 promoted neurogenesis in DZ and contributed to the improvement of spatial memory. However, the bioavailability of A2 is extremely low, and the mechanisms of these effects is still unknown. Thank you for your attention.